quantitative aspects. This is your term three, physics. So it's chemistry. So quantity, we are looking at quantitative aspects of chemical change, right? And let me start by saying, back in grade 10, we learned the difference between two things. We learned about what we call physical change. Um, we learned about physical change, and then we were also introduced to what we call chemical change. Now, what is the difference between physical change and chemical change? Um, is there anything you remember, guys, in terms of the difference between physical and chemical? Mm. Great. Wow, wow. That is very nice, ma'am. And then we formed a compound. Great, great. Now that is great. So in physical change, you talked about that a substance might be changing phase, right? Perhaps maybe changing from solid or liquid to maybe to solid, or solid to liquid, or even maybe to gas, right? Even though the correct order is from solid, liquid, gas, because solid to gas or gas to solid is sublimation and deposition. But that is very nice because you understand that in all of these, what is happening is that the substance is changing phase. You see, for example, water. Water, it can be a liquid, a solid, or a gas. That means that it can change its phase. But does that mean that you have a different or new substance? For example, if I have liquid water and then I have solid water, does that mean that the it's a new substance? Is solid water different from liquid water? No, yeah. So it's the same substance, right? That is the thing. So on physical change, you simply have the same substance, just in different phase. So physically, that's why it's called physical change. Physically, it looks different because solid water physically doesn't look the same as liquid water or water vapor. They are physically different, but the substance is the same. But when you talk about chemical change, indeed, the the parts have to be chemically bonded. The particles have to chemically bond, and once they have chemically bonded, they form what you call a what? We form a new substance. We form a new substance, and then what do we mean by a new substance? This is a substance that has different properties from the initial parts that made it. Let's say it in Zulu. Let's say you have hydrogen gas, right? Not hydrogen. I usually like to use sodium. Let's say you have sodium metal. Um, Sodium is a metal, okay? A metal that you can actually cut with a knife. That's how soft it is. So take your sodium and take chlorine, right? Chlorine is a poisonous gas. You understand? Chlorine is a poisonous gas. So you have sodium, you have chlorine. When you combine those two things, you form what you call sodium chloride. And guess what? This is simply your table salt, isn't it? It's your table salt. So wait a minute, how did we move from a metal that you could cut with a knife to a gas that was poisonous to something you can eat? You can put in your chips there. That make us. Do you understand? understand the difference? So that means, or rather, it tells us that it's a chemical change and not, it's a chemical change and not a physical change. So, when we talk about quantitative aspects of chemical change, now you get, now you're gonna get an idea of what we're talking about. Since we said the whole thing that we're seeing here is a chemical change, we said it's a chemical change. So when we say quantitative aspects of chemical change, we are then saying how much of that sodium metal did you take or combine with the gas? How much gas did you use? And then how much table salt did we form? The moment we keep answering or we answer those questions, we are talking about quantitative aspects now. Quantitative aspects of that chemical change. So the numbers, you understand, how much of something that you have, that is what we call quantity. So how much sodium, how much chlorine, and then how much sodium chloride did you form? Now, in chemistry, the part of chemistry that deals with how much of something you have, or rather how much of something you are using, that part is called stoichiometry. It's a very weird name. It's like you are saying or talking in China, stoichiometry. But you're probably going to be familiar with this because I believe in term two, perhaps you touched on it. Did you guys touch on it? Oh, you did it last year. Okay, no, that is great then because that means we are gonna revisit a bit of what we were doing last year, and then we're gonna come to how we're gonna apply it this year. In fact, you must know that it's not different, just that we are gonna add a few things in grade 11, things such as um, things such as percentage yield, right? And then limiting reagents. Those are the only things that we're gonna add. Otherwise, is the same thing that you were doing last year. So let's go back to stoichiometry. Back in grade 10, as remember we had what we call 1 mole of a substance, and this is always going to be one of the definitions you need to know in chemistry. By now, you should be familiar with the fact that physical sciences needs you to know definitions. So, what is 1 mole of a substance? 1 mole of a substance. The same number of particles as there are atoms in a carbon, in a 12 gram of carbon 12. Aha, I hope we still remember this definition. 1 mole of a substance is the same number of particles as there are atoms in a 12 gram um, um, of carbon number 12. To be honest, when you write this definition, it's like we are just writing words. To make sense of this, it's one of things that we struggle with. I myself, when I was writing this definition, to be honest, I just used to cram this, so that I just get the mark, the 2 marks in the exam. But we need to understand it. We need to understand it. So, for to help us understand this, we have to go back to um, how we count in our daily lives. Things like when you say 1 dozen of eggs, when you say 1 dozen of eggs, how many eggs is that? Hmm. Is it 12? Is it 6? Uh, is it 6? 12? 12. Okay. That is 12 eggs. And we can talk about 1 dozen. We can talk about your. I, when you don't speak English a lot, you realize that you don't really use these words, eh? But yeah, 1 dozen represents 12 eggs. So that tells you that if you have 2 dozens, 2 dozens, that will be 24 eggs. And then 3 dozens, that would be 36 eggs, right? So if someone says to you, please go buy for me 3 dozens of eggs, it doesn't mean you must go and buy 3 eggs, but you must buy 36 eggs. So that tells us that 1 dozen, it's like a unit of measurement. It's a unit of amount of eggs. So when I say, it's like we can even say 1D to give it a nice name. 1D, we know that is 12 eggs. And then we can say perhaps a 3D. We know that is 36 eggs. So this is representing 12 eggs. That is 1 dozen. It's like a placeholder. It's something that is representing something else. 1 dozen, 12 eggs. 2 dozens, 24 eggs. So how does it relate to moles? Well, since 1 dozen is 12 eggs, what about 1 mole of eggs? What do you think? How many eggs will be in 1 mole of eggs? Can you just type for me there? Remember that you can use the chat box there. On that chat box there, you can type. For example, I can type 58. Yeah. So guys, I want to know, how many eggs do you think are in 1 mole? Since we said 1 dozen is 12 eggs, 1 mole is how many eggs? Think about it. And also write it for me. 1 mole of eggs. Say, mntanami, please, ngicela ukuthi ungiphathele amaqanda. How many we tell, and then Gogo tells you, just bring me 1 mole of eggs. How many eggs are you going to come with? How many eggs are you going to give Ugo there? Um, um, no idea? How many do you think are there? Miss Ori, talk to me. Uh-huh. Okay. Okay. Well, it turns out that 1 mole of eggs would be, let me write it here. That would be 6 0 2 2 0 0 0 0 0 0 0 0 0 0 0 0. Okay, let's continue. Uh, some right 0, 16, 17, 18, 19, 20, 21, 22. Huh? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23. Right. Yeah. It will be this amount of x, guys. That amount of x. Yeah, I'll probably give you 100 rand if you can uh, tell me how would you write this number in words. I'll probably give you 100 rand if we can get it correct. But yes, it's six something, six something, and then yeah, you can see, guys, it's a big number. I don't know if it would be possible for any shop to give you this amount of eggs, but you must know that that is 1 mole. 1 mole represents so 1 mole of eggs will be those number of eggs. So that means of anything. 1 mole of anything is this number. You understand? So one represents that number there. Right. That is 1 mole. I hope that it is clear. Are we all good? Can indicate, remember, with thumbs up there if you are fine. Are we clear with that, good people? Then you can indicate there if you're okay. Okay, perfect. So that is what is 1 mole of anything. Is that number. So usually this number we can shorten it or write it in scientific form. So we can write it as 6,02 multiply by 10 to the power 23. Okay, so this is like a shortened version of that. So this is a shortened version of that, but when you expand it, it becomes like that. That is 1 mole. And when we say the same number of particles as there are atoms in a 12 gram of carbon 12, the thing is that scientists, they chose carbon. Remember, carbon has I think the atomic number is 6, and then the mass number is 12. Name. So that tells you that these carbon atom, what they did is that they measured how many atoms are in 12 gram of this. You understand? They measured how many atoms are in 12 gram of carbon. Then they found that the amount of atoms in there was this. And then those atoms, then they called them um, they call that those number of atoms, they call them a mole. And it's Avogadro actually did it, ne? So that is why this is called Avogadro's number. Yeah, so it's Avogadro was busy with that. So he discovered that in 1 mole you have those number of particles. So if I say 1 mole of a sweets, that is that number of sweets there, right? So now that we understand what is a mole, right, there is now a way in which you can use to calculate a mole. Okay, so to summarize it, we're gonna say if you have n, so if you know the number of moles of a substance, you are able to convert those number of moles that you have to mass using the formula n is equals to small letter m over the molar mass. Okay, so you're gonna use this when you are talking about solids. Mostly gonna use this when you talk about solids. Know that m is mass and it is measured in grams, and then the big letter m is molar mass. Okay, it's molar mass and it's measured in grams per mole. That one is measured in grams per mole. So small letter m is mass, in grams, and then the big letter M is molar mass. By the way, the molar mass, you get it from the periodic table. This one, you get it from the periodic table, if you remember from grade 10. Right. If you also have number of moles, you can convert those number of moles into volume by using this formula. Okay. So, this V, this you usually use it for gases. Okay. This one you usually use it for gases, and that V is volume, and our volume, we measure it in decimeter cubed. That's how we measure volume in stoichiometry. The units are measured in decimeter cubed. And Vm, what is Vm? Molar volume. Okay, just as we had molar mass, we also have molar volume. And the units, yeah, it's going to be decimeter cubed per mole, right? Yeah, decimeter cubed per mole. But these ones, we don't really, the units, we just need to know that it's decimeter cubed per mole. And the molar volume, right, at Tp, at standard temperature and pressure, the molar volume is gonna be 22,43 decimeter cubed per mole. So this is usually given at the end of your question paper, meaning in the data sheet, right? You can check there, the molar volume is given, but you only use it as 22,43 if it's at STP. Otherwise, you must be told what is the molar volume if it's not at STP. Okay, and then if you have number of moles, again, you can also calculate concentration by saying N over V. Okay, so this one, you usually use it for aqueous solutions. So when you have aqueous solutions, you use it. So it's for solutions, and N is the number of moles, and then V is the volume. And the volume is simply in decimeter cubed. Then concentration itself, C is concentration, and the units for concentration is what? Mole per decimeter cubed. Mole per decimeter cubed. Alright, finally, the last one. If you have number of moles, you can get the number of particles, which is represented by the capital letter N. Okay, so this is when you are looking for the atoms or molecules. You're looking for number of atoms or number of molecules. And then Na, please know that it is the Avogadro's number. Na is the Avogadro's number. And remember, it's 6,02 times 10 to the power 23. It's given at the formula sheet. Right. So I usually say to my grade 10s, as long as you get the number of moles, then you can get anything else that you want. Okay, are we clear? And please just have maybe this formula somewhere, because we might need to use them in our next section. Gonna check some problems then, so we're gonna apply those formulas, so just write them somewhere. So as soon as you're done writing them, you can just maybe give me a thumbs up. Can we write in scientific notation? Yes, 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 yes. Please do write it in scientific notation. Because if you write it in that number, you won't finish. Okay, perfect, perfect. We have all of them. All right, 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 right. So we're gonna check some problems here and see if we can solve them. Um, just give me a second. Where is that? Mm, great, great, great. Okay. Um, so let's have a first one here. Just gonna quickly type it in. Now, uses Andy uses 5 grams of sodium and mixes it with a 10 decimeter cubed. I'm just gonna write cubed after. So Andy uses 5 grams of sodium and mixes it with a 10 decimeter cubed um, volume of gas, volume of chlorine gas. Um, how much sodium chloride is produced? How much sodium chloride is produced in terms, or let's say how much mass of sodium chloride is produced? Perfect. Okay, so there, let me just put the cubed, the decimeter cubed. Sure, let's put the decimeter cubed here. Perfect. So Andy uses 5 grams of sodium and mixes it with a 10 decimeter cubed volume of chlorine gas. How much mass of sodium chloride is produced? Right. Very, very, very beautiful question. So, you have the formulas, ne? But I'm gonna walk you through in terms of how do you do it, right? And then, I will give you questions after. I will give you to do on your own some questions that are coming after. So the first thing you want to have here is the chemical reaction. So usually the chemical reaction is given to you, but you just never know, ne? So sodium uh, reacts with chlorine gas, and then we form sodium chloride. Now, okay, it's a solid. We need to make sure that we balance the equation also. Please, please, please. You always make sure that the equation is balanced. Because if you do this without balancing the equation, you'll probably get wrong answers. So here we are. We have to put a 2 there so that there are also 2 chlorines, but it affects the sodium. Now there are 2 sodium atoms to the right. And here we have only 1, so we need to put a 2. I hope that with balancing, guys, we are okay, ne? If you have troubles with balancing, you need to inform me so that we perhaps go through the basics. So yeah, feel free to drop me a message in case you are struggling with that. So now, how do we find how much mass of sodium chloride is produced? Here is sodium chloride. You need to list out the information that is given. Remember, you're given that we have 5 grams here. What is this 5 gram? you need to categorize it in terms of, is it mass, is it volume, is it concentration, is it number of moles. What is 5 grams? Is it C, N, V, or M? C, N, V, or M? Let me hear from you guys. Where does it fall under? Small m, ne? Great, great. Oh yeah, because there's a capital letter M there. So we have a small m there. So that is okay. And then we have 10 decimeter cubed volume. So that was already given that for chlorine. For the chlorine gas, we have a volume of 10 decimeter cubed. So what do we do with this information that is given? The first step is to convert what is given into number of moles, because remember from the previous information we said you can't do anything without the number of moles, so you need to get the number of moles first. But how do you get the number of moles there, right? So you just have to check in terms of the formulas which one has small letter m, because this is small letter m, right? So you have to check this one has small letter m, so therefore you can use this formula. That's how you pinpoint your formula. So we can use this one because it has small letter m, so we know that we're gonna use n is equals to small letter m over capital letter M. What about this one? Now the question is, this one also has given information, it's V, right? Then if I check, the formula that has V is this one, right? So why not use, which one are we gonna use now? Am I gonna use this or am I gonna use that? Now please tell me guys, what do you think is the most appropriate formula to use here? Should we use this or should we use this? A or B? Which one are you going to choose? A. Why A over B? You calculated the molar mass. Okay, perfect. I know that is nice. That is nice, but I still am not convinced. Why wouldn't B work? I mean, can't we use B for real, like? But I understand. So you saying we should use the first one. Any other suggestion? Miss Ore, which one would you choose? Is it A or B? Mm. Oh, I see. Okay, no. That is fine. I understand. All right. So, indeed, that is true, Miss Ria. We should use A because A. The reason why we're gonna choose A, it's because we are able to calculate the molar mass, and then we have the mass that is already given. But the problem with using this one is that yes, the volume is given, which is V, okay, but do we have the molar volume? Well, you might say no, but say use the molar volume, we use it as 22,43 decimeter cubed per mole, right? But the reason why we can't use that here in this case is because they didn't mention that it is at STP. So we only use n is equals to v over v, and then we use the 22,43 if they mentioned that it is at STP, at that temperature and measure. So because it was not mentioned, it is probably not best to use um, this formula there. Okay, I hope that is clear. We are not just saying, no, this one looks nicer, but we actually not using this because we don't know what is VM, since they didn't mention STP. All right, so let's use the n is equals to m over m. So n equals to, the mass is 5 grams. Now, how do we get the molar mass? Now, the molar mass, right, you go to your periodic table. So I'm going to show you a periodic table here real quick, and then we're going to use that periodic table to get the molar mass of that substance there. Hoping I show the part that has those. Right, so here's my periodic table here, and then we are trying to calculate for yeah. So for sodium, you just check sodium on your periodic table. As you can see, is 20.
What would be the answer there? 5 divided by 23.
It's 0,217. I'm not sure if it has other decimals. Please check for me. I'm getting 3 decimals. So I don't trust this calculator of mine. What do you get? Can you round it to 4? 2174. Okay, great. So when we have not reached the final answer, we use 4 decimal digits. So great, we got the number of moles, but please remember that it's the number of moles for the sodium. Okay,
We, we got number of moles of sodium. So how do we get the number of moles of sodium chloride?
well, which formula has m, small letter m? Because we're looking for mass, right? Which formula is small letter m? I believe is still the same formula. So it's going to be, so we're gonna use that formula. N is goes to small letter m over the big letter M. Okay, but remember now we are talking about sodium chloride. So what are the number of moles of sodium chloride? We don't know, because do not say that the number of moles of sodium chloride is 0,2174, because those are for sodium. You understand? So for sodium chloride, we do not have, we are not told in the question how many moles of sodium chloride we have. We're not told, isn't it? So we do not have. What about the mass? We also don't have the mass. And it's the one that is asked in the question that we need to get the mass. What about the molar mass? Well, the molar mass we can get always from the periodic table. Okay, so let's substitute whatever we have then. So we don't have mass, but the molar mass for sodium, um, remember molar mass, you go periodic to the periodic table. For sodium is 23, so you're gonna write 23 there. And then you say plus. Why are you saying plus? Because we're talking about some chloride. It's
Avogadro's number.
Aish. Then we are stuck, man. We are stuck. Right? We should just leave physics. You know, physics is difficult, Sam. This is why I don't like physics. No, 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 guys, it's very easy. Don't worry. So, what you can simply do there, uh, I'm just gonna remove this, okay? Because we already have it here. So, understand this, guys. Since we don't have number of moles for sodium chloride, right? Uh, when we say stoichiometry, we mean that you can be able to use what you have, the number of moles that you have, you can use them to get the number of moles that you do not have. The number of moles that we have are for sodium. Those are the number of moles that we have. So we can say the number of moles of sodium, we can compare them with the number of moles of sodium chloride. Why? because this is the one we have, and then this is the one that we want. This is the number of moles that we want. This one is the number of moles that we want. Okay, so number of moles you are able to compare. So, and you are able to do it for any two compounds, or any two atoms, or a compound and an atom. You are able to do that on the chemical reaction. That means if I want, I can say number of moles of sodium is to number of moles of chlorine, is to number of moles of chlorine. You understand? But because I'm not interested in chlorine for now, there's no need for this. So I just say number of moles of sodium is to number of moles of sodium chloride, because that's the one I'm interested in. Then what do I do? I'm gonna look at these numbers. Do you see these numbers? These numbers. For sodium, it is 2, right? And then for sodium chloride, it is also 2. Those are called molar ratios. Okay? They are called molar ratios. And you can use molar ratios to get the number of moles of anything that you want, as long as you have the number of moles of the other one. You see? So now, after you are done with the molar ratio, you then say the number of moles of sodium that I have, it's of moles of sodium chloride we don't have, so you can call it X. Just like you have X in maths, you just call it X because this one you don't have it, right? Then what do? You are going to cross multiply. It's just simple cross multiplication here. Okay? And then you simply solve for X. You will always be solving for X here. So you have 2 is equals to um, 2 multiplied by 0,2174. Then how do we get X? You divide by 2, you divide by 2, and therefore you get your X to be 0,2174. Nice. So this X represents the number of moles of sodium chloride, which means now we have the value for that part.
So, what? But let's simply recap and so here are the steps when you're dealing with stoichiometry.